So it's about time for a new Unity tutorial video. It's been quite a while since I've made one of those. I've actually been pretty active on YouTube. I've been making music videos using Unity, and I've also been busy uploading conspiracy theory videos to my conspiracy theory channel. So links to both of those channels are in the description. But some of the music videos that I've made have done pretty well. This one is getting close to 1 million views, and you know, almost 500,000 on this one. And this is a brand new one that I just uploaded that I made using Unity, of course. And some of these are actually 360 videos, and the 360 videos will have the visualization for the audio. And if you've actually tried to do this, it gets pretty complicated because you can't play back the audio in real time during the video render, and all the scripts to visualize audio pull from an actively playing audio source. So it becomes pretty difficult. I got an email about this recently that basically sums up this problem using 3D Panorama and Rhythm Visualizer. And when you go to render, you just get a flat line on this, visualization. So this tutorial is going to cover how I render some of these videos, including audio visualization in a 360 video. Okay, so I have a brand new Unity scene here, and it's Unity 2018.2.19. And the first thing we're going to need to do is get the Rhythm Visualizer Pro. So I'm going to go ahead and import that package. And it says there's a null reference exception. Clear that out. We don't need to. I'm just going to work in the scene, in a brand new scene, so everything's how I would normally make a video, which is to work with a new scene. And I'm going to bring in the Rhythm Visualizer Pro prefab and hit play. And we should get a null reference exception because it's trying to find the main camera. We need to put the tag onto the main camera of main camera. Now it should work, but there's no audio. You should really get a 10-second music or 5-second music clip to work with. I have a 10-second audio clip right here. This will save you a lot of time if you work with a short music file like this. And the Rhythm Visualizer Pro needs an audio source. It has one attached to it. I'm going to remove that, and we're going to add a new game object and add an audio source to that. Now this is going to be the audio source for Rhythm Visualizer Pro, so I'm going to drag this right here, and let's give it a name. This is the audio import export. We'll just call it that. So we have changed the audio source on Rhythm Visualizer Pro, and this one's going to need a new script on it. I'm not sure what to call it, so I'm just going to call it audio import export. New script, audio import export. And let's go ahead and open this up. What we're going to do is we're going to play the audio file in Unity and use audio source.get spectrum data to save it all into a list of float arrays, and then we're going to save that into a file on the hard drive, and when we render the video, we'll be able to load the spectrum data from that file instead of getting the spectrum data from the speakers. So in audio import export, we're going to need a couple of booleans. I'm going to do them public so we have easy control of them, and it's going to be public bool load data from file and save data to file. So one bool to load and one to save. We're also going to need that list, and I'll make it public. So a public list of float arrays. And the float arrays are, this is the spectrum data, so I'm going to call it spectrum list. And this is a new list of float arrays. And because I'm going to save this into a file, I'm going to serialize the field. Now, just a quick note, I'm only going to work with the left channel for music visualization. I think that's enough for a simple music video. If you really need the left and the right spectrum separately, you're going to need to make two variables. And whenever I'm working with this spectrum list throughout this tutorial, you'll need to duplicate this 2 times so that you have a spectrum left list and then you have a spectrum right list. But again, for the purposes of this, I'm just going to mirror the left to the right channel, and I think that's good enough for a basic music visualization. So we have a spectrum left list. That's just going to be the spectrum list. And we're going to need access to the audio source on this game object. So audio source, we'll just call that one audio source. We're going to need access to Rhythm Visualizer Pro. So I'll just do a private Rhythm Visualizer Pro. We're going to need a Boolean, a private Boolean, to know if the data has been saved or not. Have we successfully saved it to a file? So just a couple of things. When it starts, we're going to populate the audio source, and the audio source is going to be equal to get component audio source, since it's on this game object. And let's go populate Rhythm Visualizer Pro. That's going to be equal to, there's probably a better way to find this, but let's just say get component by type, game object dot get object, find objects of type, and we're looking for the Rhythm Visualizer Pro. And when we find that game object, we're going to have to do a get component Rhythm Visualizer Pro. Again, there's probably a better way to do that, and if so, let me know in the comments. But we've got the audio source and we've located the Rhythm Visualizer Pro. So let's proceed to the update function. And first thing we're going to need to check is if we want to save the data to a file, let's save the data first and then we'll load it. So if save data to file, we're going to check if the audio source is plain. And so if the audio source is plain, what we're going to want to do is make a new float, or a new float array, and we'll call this spectrum, and that is equal to a new float. The size of the float needs to be equal to the size of the channels that Rhythm Visualizer Pro is using. And I know that I'm going to use 4096, but if you want to check, let's go ahead and open up the Rhythm Visualizer Pro script. And in the Rhythm Visualizer Pro, underneath the variables, we could see they have the channels, and that's this channels variable, and it has a channel value set to 2048. If we look at the Rhythm Visualizer Pro script here, we can see the channels value is set to 4096. So it's going to be set to 4096. If you do less channels, your file size will be smaller and the rhythm visualization will probably look just as good. So consider lowering from 4096 to a lower number. But on this tutorial, I'm going to keep it at 4096, and you don't have to change it, but I'm just going to go ahead and type in 4096 right there, since I know that that's how many channels we're going to use. So back to audio import export script. We are making a new float array called spectrum, and that is equal to the number of channels that Rhythm Visualizer Pro is using. And now we're going to do audio source dot get spectrum data, and this wants a float array for the samples, so that's the spectrum that we just created. And it wants to know the channel. 0 is left and 1 is right. Because I'm just getting left, I'm just going to put 0 here. And then it wants to know the FFT window. This is the method. This is the method for getting the spectrum data, and we could see that it has one here, and it's the default is set to FFT.Blackman. So let's just go ahead and pull this FFT value from there. We're gonna do Rhythm Visualizer Pro dot FFT. I think it's called method right here. So audio source get spectrum data. So it's gone ahead and got the spectrum data and it populated it into this float array. Now we're going to add this float array to our spectrum list. So spectrum list dot add, and we're going to add spectrum. So on each update of the game, it's going to go get the spectrum data and add it into this list. So now it's going to play through the whole audio file and get done. We're going to go ahead and do an else if here. So else if the audio source is not playing. So audio source dot is playing is not true, and we're also going to make sure that the data saved variable is false. So audio source is playing false, data saved is false. That means it's got to the end of the song. It saved all the spectrum data to the list, and now we need to save it into a file. So to do that, I'm going to use a file stream, and that means that we're going to need to use system.io. I'm going to call that fs, and that's equal to a new file stream. And for the file, I'm just going to call it spectrum.dat. If I don't put a folder here, it's just going to save it to the root of my project folder, and that's fine with me. So we need a file mode.create, and we're also going to need a binary formatter. And in order to use this, we're going to have to use system runtime serialization formatters.binary. So I'm going to call this one BF, and that's going to be equal to a new binary formatter. Now I'm going to say binary formatter.serialize, and we're going to serialize with the file stream, and we're going to serialize the spectrum list. Now that that's done, we're going to close the file stream, and we're going to set the data saved variable to true so that it doesn't try to save the file more than once. The other thing that I'm going to do here is I'm going to say Unity editor dot editor application dot is playing, and is playing is going to be equal to false. That way I make the Unity editor stop playing when it's done saving the file. And now we can check if this is going to work. If we go back to Unity, on the audio import export, it's set to load data from file, save data to file, and none of those are true. That's okay. Let's just check and make sure everything's working. If I hit play, we should get this, but let's make sure the play on awake, and we give it a clip of this 10-second clip so that we check if the rhythm visualization is actually working. Looks good. And normally all these videos, you're not gonna have camera Rhythm Visualizer Pro do camera control, so I'm just gonna turn that off. Alright, so everything's working, and I want to save this spectrum data into the file. So if I say save data to file and I hit play, Okay, I think it worked because Unity Editor stopped. So if I right click on assets and show in Explorer, there's the spectrum.dat file, and I see it's 9 megabytes. So that's a pretty big file for 10 seconds of music. It's 1 megabyte per second. And now that we've successfully saved spectrum data to a file, we're going to need to load it and have Rhythm Visualizer Pro use that instead of the audio source. So back to the script, audio import export, and I'm going to do this in the awake function. So void awake, and the first thing we're going to just check if load data from file is true. We're going to go ahead and load the data in the awake function. So we're going to say using stream, we'll just call it stream, and that's going to be equal to file.open. We're just going to open up this file, of course, so paste that one in here, and that's going to be file mode.open. Alright. We're also going to need a binary formatter BF, and that's going to be equal to a new binary formatter. And then we're going to say spectrum list. So this list we're going to populate from the binary formatter. That's going to be equal to list of float arrays and binary formatter dot deserialize the stream. Alright, so now that should read our file and repopulate this list, spectrum list, with all of the spectrum data. And now Rhythm Visualizer Pro can pull from this list of float arrays instead of the audio source. And to make the Rhythm Visualizer Pro do that, we're going to need to come over here into Rhythm Visualizer Pro, do a search for audio source dot get spectrum, and we found it already. The first place it finds it is emit if there are rhythm. Okay, so in emit if there are rhythm, we're going to need to comment these out because we can no longer pull from audio source dot get spectrum data. We have to pull from our list. So spectrum left data is going to be equal to this audio import export script. So audio import export. We're going to need to define an array or a variable for this. So I'll just make it public and assign it manually. So public audio import export script is audio import export. And we're also going to need the index of the array, and that's going to be the current frame that we're on. So I'm going to make a private integer called current frame. Okay. So right back down here to the first instant of audio source.get spectrum data, we need to assign a spectrum left data and a spectrum right data. And that's going to be equal to audio import export dot spectrum list, and the index is going to be equal to the current frame that we're on. Now, spectrum right data we're not really using, we're just mirroring it, so I'm going to say spectrum right data is equal to spectrum left data. So that takes care of emit if there are rhythm. We still need to increase this current frame count, but we're going to do that in late update. So let's go ahead and expand into the base script. That brings us to late update. And in late update is the next spot where we find audio source, audio listener.get spectrum data or audio source.get spectrum data. This is checking for a few variables that I know are going to be, that I'm not dealing with. This listen for the all sounds, we don't have to worry about that because we are using an audio source. And we don't need to worry about this mirror check either because we actually are mirroring. So we can go ahead and just delete this one. And we don't need to check if the audio source is null because I know that it's not null. So we've eliminated this whole area down to just these 4 lines. And we still can't use audio source.get spectrum data. These need to get commented out, and they need to get replaced with, of course, the audio import export script spectrum list current frame, and the spectrum right data is going to be equal to the spectrum left data. And now we can go ahead and increase the current frame, because the first time this runs is going to be 0, and we want it to be 0 the first time, so I'm not going to do the current frame plus plus until after we've pulled the spectrum data once from an index of 0. Okay, so let's see what's going to happen. I think I've done everything right. We're going to change this variable from save to load, because we know the file already exists. It's right here. So we're going to go ahead and switch that variable to load. And I'm also going to turn off play on awake, because I don't want any audio coming out of the audio source. But I want to see if it'll do an audio visualization. And it won't. I got a null reference exception. And it came right here from the current frame, because I never assigned the audio import export scripts right here. I just need to populate that. I had never populated it. So let me try that one more time. And there we go. We get the audio visualization without any audio playing at all. And this will work when you do a render. But we're getting an argument out of exception range. So the reason why is the current frame has gone beyond the size of the list. So we're going to need to do a check right here. If the current frame is greater or equal to the audio import export spectrum list count, then the spectrum left data, we're just going to set that to a new float array 4096 number of channels that we're using. And the spectrum right data is going to be equal to the spectrum left data. That's just making it like a 0. There's no audio playing. And then we'll say else, grab it from the list, and that should avoid this argument out of range exception. So one more try here to make sure we don't have any errors. It's going to play once per frame, so when you're rendering the video and it goes once per frame, it's pulling the correct audio. And there we go. Everything's working fine. So we can save the audio to a file. We can load the audio spectrum from a file. So now we're ready to render a video. We need to import the VR Panorama. And this one's good for rendering any videos, not just 360 videos. So I'm going to go ahead and import the pack. And it's giving me errors about a first-person controller. I don't need that standard assets character. I'm just going to delete that. And that should clear away the errors. So this one you just work by adding the script VR capture to the main camera. And you could set up your settings here. I'm doing a 360 video, and it's 2048 by 2048, and I'm going to do 30 frames per second. 30 frames a second, number of frames to render. Well, my song is 10 seconds long, so it should be 300, but it's starting from frame 1, so it needs to be actually 301 to be 10 seconds exactly. And that should be all the settings I need for the VR Panorama. But if I render this right now, it won't match up because my screen is 60 frames a second and that means update is running at 60 frames a second. So one thing I'm going to need to do is I'm going to need to do a search, because Rhythm Visualizer Pro sets this value, and it's application dot target frame rate, and target frame rate is being set to 144. I don't know why it's at 144. I'm going to set it to 30. So application.target frame rate is being set to 30. And in order to make that work, you're going to have to go to the project settings, quality, and on vsync count, instead of every v blank, say don't sync, because don't sync is the only way to get application.target frame rate to actually work. So I'm going to save that, and I'm going to re-export this data, because you're going to notice it's 10 megabytes. And now that I've set the frame rate to 30, if I go here and I do a save data, play the music. Uh-oh, we don't want to render a video. I need to disable the VR capture script. One more try. So this should re-export, and look at, it's half the size, 5 megabytes, because we've gone from 60 frames a second to 30 frames a second. So I have your audio export needs to be at the same frame rate as your video is going to be. So now that my audio export, I'm going to go back here and say load data from file. We're not going to play the audio from the audio source. Rhythm Visualizer Pro is still working, and we're going to turn on the VR capture script. So I'm going to go ahead and say render panorama, or click play will do the same thing. And once this is done, it's going to have ffmpeg automatically render that video. And I might as well get Adobe Premiere going. So it's finished rendering the video. Here's the MP4, and let's bring that into Adobe Premiere. And we also want to bring in our 10-second, bring in our audio song. New sequence from clip. And I'm zoomed in on this, but you can see it right here. And let's bring in our audio into this. Okay, so here we are, and they don't quite match up. I think that this one goes to the end, and we need to actually start the VR Panorama record a couple seconds earlier. But you'll see here if we can match up the audio with the video. And that's why I'm going to do a zoom in. And I could look at the audio waveform and look at this one down here and try to see if it matches. And I think it does, but you can try to match by looking for a vertical wall here and find where it peaks right here. So I see that there's this huge vertical wall, which is right here, is this vertical wall right here. So this actually needs to back up. Move this one maybe 2 frames. So right when I get to this vertical wall is when the video's showing that. Now to get to make this capture a little bit sooner or a little bit later, it should be pretty obvious how to get that done. If you want to record longer, you just increase the number of frames to render right here. So it's a probably good idea to, you know, go 5 seconds before and 5 seconds after. And the way you would do that is start with the VR capture script disabled, and number of frames to render. I want more than this. Let's at least do another second. So that's going to be 331 seconds. And the VR capture script is starting off, and then we're going to enable that as soon as the after like a couple of seconds. So after Awake has loaded the file, then we're going to start a coroutine to turn on the render. So let's just do a real quick private IE numerator start record, and we'll do a float delay, and then we're just going to say yield return new, wait for seconds, and we're going to wait for the delay, and after that we're going to go for Rhythm Visualizer Pro .game objects .enable or set active is equal to set active true, and that's going to start the render after a short delay. So let's just say start coroutine, and it'll be start record. We're going to say wait for 5 seconds. That's not quite going to work because I told it to turn the game object on, but we want Rhythm Visualizer Pro .enabled is equal to true. That actually turns on the Rhythm Visualizer Pro component. Wait, the VR capture. I'm making a big mistake here. We need VR capture .enabled equal to true. So VR capture .enabled is equal to true, and we're going to need a private VR capture, and that's VR Panorama.VR capture if we don't want to say using that namespace. And then when it awakes, we're going to go ahead and do a VR capture is equal to find object of type VR Panorama.VR capture, and then VR capture.enable is set to true. And now if we press play, what's going to happen is it's going to start showing the Rhythm Visualizer Pro, but it's not recording yet. We need it to wait. So if we go back to the Rhythm Visualizer Pro script, and we had this variable for current frame, and we're advancing that current frame plus plus. So current frame plus plus, we're going to need to wait on this until we start recording. So there's a bunch of different ways to do this, but I think just to get it nice and easy, we're going to do a public bool is recording, and whenever we start the record, we're going to set is recording to true. And then in Rhythm Visualizer Pro, so here we could do an else if, and we're going to check if the audio import export is recording, then it's going to go ahead and get the spectrum value from the list and increase the current frame. That leaves a situation where there could be spectrum data left and right null, so we need to at least make sure it has some value. Alright, so that should make the error go away, and if we press play, it should go ahead and start. It should be flatlined on the Rhythm Visualizer Pro until the recording starts, and once the recording starts, then it does the visualization. it's going to record for an extra second after the song has ended, which we need that extra padding. It's going to render the video with ffmpeg, and once again, let's bring that into Adobe Premiere. And I don't remember which one was which, so I'm going to bring it in one more time. And we can see the video is longer now, so that is good. That's exactly what we need. And now we just have to line up this audio with the video. So in the beginning, it should actually be right at the beginning, but we'll see. And what we're going to look for is just a vertical line like this one right here, and see in the video where that peaks. And it looks like sometimes it's easier to start at the first one. So we could see this bump right here. That has to be this bump right there. So this needs to match up with that. And you probably want to go towards the end of your audio file and do the same type of check. There's one little bump right here. Or try to find even a bigger wall, maybe this one. So I can see here that there's a vertical wall here, and it happens right here in the video. So it looks like I need to shift the audio one frame forward still. Now, I don't know if you'll need to do this, but it seems like on most of mine I need to set the speed or duration to 98.6, and that actually looks like it puts it at 98.49. The video itself, and I don't know why that is, because everything's matched up, everything's both 30 frames a second, but it seems like to get the audio to match up perfectly, I've had to shorten the video just a little bit in Adobe Premiere. So that looks good to me, and it covers the entire audio file. We have video before the audio begins, and we have video after the audio ends, and that kind of allows time for some of this visualization to finish up. So saving to a data file and loading from a data file is one way to do it, and in my next tutorial I'm going to show how to do this on the fly, basically doing it from memory, loading, analyzing the spectrum data, saving it to memory, and then rendering the video all in runtime without saving or loading anything from external data files. But this is one way, and I wanted to cover this, and this is how I've done most of all my original VR music videos. So stay tuned for the next episode in this where we do all of it, analyze everything in runtime instead of using data files. And thank you for watching. I'll see you guys in the next video.